This is chapter 2, the Ohm's law. In this chapter, we're going to talk about voltage, current, and resistance. In session 2, we are going to learn the most important law in electronics that is called the Ohm's law. There are 3 Ohm's law's formulas. In session 2.3, we are going to learn electric energy and power. For 2.4, we're going to spend more time in resistors. In session 2.5, we're going to learn the rules for drawing circuits. Now let's begin session 2.1, voltage, current, and resistance. The 3 stooges. These are the 3 fundamental quantities in electronics. So let's begin with voltage. Actually, we see voltage very often. Over here, there are different types of batteries. The first pack has 4 AAA batteries. Each AAA or even AA battery provides 1.5 volt. The next one is a 9 volt batteries that provides 9 volt. And then the last one, the bulky one, is a car battery. This battery provides 12 volts. Here has more products. You may see voltage labels such as these tools. It has circular saw, drills, reciprocating saw, hammer drills. They all need to be powered by the batteries. These batteries are showing here. Let's focus on this battery and then we pick one of the two, zoom in and then spin it. The label shows it provides 20 V, which is 20 volt. This is another example. The light bulb shows voltage. The label shows this light bulb works between 12 to 48 volt. The second quantity is the current. Some electronics devices also labels the current it can handle. Such as these 2 devices, these are called relay. Relay is an important electronic device that we can use it to control current flow. If you look at the top of this relay, it shows 10A, 10 ampere, where A is the unit of current, it is ampere. The last quantity in this list is the resistance. Over here, there are 2 piles of resistors. The resistors to the left are in light brown color, and the resistors to the right are in blue color. They are just different brands. How about let's just focus on the light brown color resistor. So we put the blue resistors away. Pick one resistor and then put in the center. Rotate it and then let's zoom in. As you can see, this resistor has 4 color bands. If you read from left towards right, the first color band is gold. If this is the case, the resistor is in the wrong direction, which means we need to flip this resistor. The last color band, the color band all the way to the right, that should be either gold or silver. So we flip this resistor. The 4th band is the gold band. Resistor is in the correct orientation. The first color band is brown, second one is black, and then we have red, the last one is gold. Every color represents a number, and these numbers are showing in this table. For example, black color means 0, brown means 1, red means 2, orange is 3, yellow is 4, green is 5, blue is 6, violet is 7, gray is 8, and white is 9. For the 4th color band, gold means plus and minus 5%, and then silver means plus and minus 10%. The first 2 color bands of a resistor represent the first 2 digits of its value. The 3rd color band represents how many zeros after the digits, and then the 4th color band represents the tolerance. This rule works for this 4 color band resistor. We also have 5 color band resistor, so the rule changes a little bit. For this resistor, its value is 1000 ohm with plus and minus 5%. The plus and minus 5% means the exact value is in this range. When the manufacturer made it, it is not exactly 1000 ohm. It can be a little bit more or it can be a little bit less, but the actual value should be in the range. Otherwise, it's a defect resistor. Now let's go over the symbols that represent voltage, current, and resistance, and each quantity's unit and the symbol for every unit. All the information is summarized in this table. The first quantity is current. The symbol we use to represent current is I. This is more like a universal symbol. Any textbook uses the same symbol I to represent electric current. The unit for current is ampere or amps. The symbol for amps or ampere is uppercase A. The second quantity is voltage. The symbol that represents voltage can be E or V. E stands for electromotive force, but V is the symbol we use more often. How about from now on, let's use letter V to represent voltage. The unit for voltage is volt, and the symbol for volt is uppercase V. The last quantity in the list is resistance. The symbol we use to represent resistance is R. The unit for R, the resistance, is ohm. Ohm is a physicist. He's the one did research on this area. To give him some credit, we use his name to represent a unit of resistance. The symbol that represents ohm is this horseshoe-shaped Greek letter called omega. For example, for the current, I equals to 5 amps, 5 ampere. Next, voltage, V equals to 120 volt. And then the last one, resistance, R equals to 100 ohm. Now let's discuss current. Electric current is defined as the time rate of flow of electric charges. The keywords here is the time rate of the charges, which means how many charges passing through a point per unit time, which means per second. The symbol for current is I, the unit is ampere, amp, or preferably just call it A. The schematic symbol of current is an arrow. Most of the time, we should draw the current arrow along the circuitry, depending on the direction of the circuitry. Next, we have resistance. Resistance is a measure of the ability for a material to resist electric current flow. For a big resistor, it can resist more current. For a small resistor, it only can resist less current. Resistance does not need to block current. It limits current or reduce the amount of current in the circuit. The reason we need to reduce the current flow in the circuit because too much current can damage some electronic devices. The resistor symbol is R, unit is ohm, or preferably just use omega. Its schematic symbol is this green zigzag symbol. The two lines are wires and the two bubbles are the terminals. The bubbles are optional. We don't have to draw those bubbles most of the time. Now let's talk about voltage source. Voltage is an electromotive force, or the potential difference. It's the electric potential that can provide current in the circuit. The symbol is V, unit is volt, preferably just use V. Here are symbols for two different kinds of voltage source. The one to the left is a single cell DC source. The symbol to the right is a multi-cell DC voltage source. It has more than one battery connected together. Here we have one analogy to show the quantities and their relationships. As you can see, we have mountains here. These are pretty tall mountains. On the top of the mountains, there are glaciers. Because of these, it forms a waterfall or a river. In the river, there is a rock. It also has fish, and the turtle swim inside the river. The water flows all the way from the top of the mountain to the bottom of the mountain. This water is like the electric current. The cause for this current flows is the height of the mountain. The rocks, fish, turtle, and other things inside the river, they all resist current from flowing faster. So these are the resistors. This is 2.1.